A chemical reaction is a written symbolic representation of a chemical reaction. The reaction chemicals are given on the left-hand side and the product chemicals on the right-hand side. The law of conservation of mass states that no atoms can be created or destroyed in a chemical reaction, so the number of atoms that are present in the reactants has to balance the number of atoms that are present in the products. For our first balancing equations problem, we are going to have xe plus f2 equals xcf6. And basically, what you gotta do is separate into two columns, and you'll write out each element. So from here, what you want to do is you want to look at the subscripts. So xe, there's 1, there's 2 f's, there's 1 xe over here, and there's 6 over here. So you want to go element by element. So what you do, you already see that the xe, they both have 1 atom each, so you don't have to worry about that. So you look at the f's, and you see that there's 2 here and 6 here. So you got to figure out how to balance them out. So you can multiply this by 3, or multiply by 3, not cross it out. So then that would get you to 6, and they would balance out. So that means you put this in front, and that's problem number 1.
Okay, so for our next equation, we have Ag plus H2S, which yields Ag2S plus H2. So first what we got to do is we got to put down each element from each side of the chemical equation. So for over here, we have 1 Ag, we have 2 hydrogens, and 1 S. On the product side of the reaction, we have 2 Ags, we have 2 H's, and we only have 1 S's. So as we can see, the H's equal each other and the S's equal each other, but the Ags do not. So for over here, we have to times this one by 2, so that this could equal 2. If you take this number here, and you put that right in front, so that it's 2Ag plus H2S, which yields Ag2S plus H2. Balanced chemical equation.
Alright, for our third problem, we have FeCl3 plus NaOH yields FeOH3 plus NaCl. So same thing as before, make our 2 columns, list each element out, and to make it easy, make sure you separate these so that you won't have any problems. So write the amount each element has. One. So the FEs are already equivalent. The CLs are not. The NAs are, the O's are not, and the H's are not. So let's start with the CL. So here we need to multiply this by 3 to make this equal up to up here. So when you multiply the CL by 3, it also changes the NA, because if you put a 3 here, it also changes NA. So you got to go to the NA on this side, change that, multiply that by 3, so you get 3, and now that makes this side not equivalent. So now you have to go here and times this by 3, that will get 3. And then as you realize, when you multiply the Na by 3, it will also change the oxygen and hydrogen. So now you have to times the OH by 3, the O by 3, and the H by 3. Now magically, that makes that equals out the O's and the H's. So now all you have to do is put a 3 here and a 3 here. That's how you do it.